Here's an example of the derivative of the inverse of a function. So here I have a function f, and what I know about it is that it has a coordinate 3, 8, and at 3, the slope of the function is 5. So if I made a little sketch at 3, 8, I have this curve, and I'm not really sure what it looks like, but I do know it has a positive slope there. And that positive slope is 5. So f prime of 3 is 5. Now, if you remember with inverses, if we're looking at the inverse of f, okay, on the inverse of f, if I have an ordered pair 3, 8 on f, that means on the inverse, that ordered pair is 8, 3. So I'm going to draw that. Okay. And I do have symmetry about the line y equals x. And so I do have some sort of curve then for my inverse of f that looks like this, kind of mirrors my original function. And let me label those for us. Okay. And so if the slope at 3 for f is 5, then that means I can conclude that at 8, the slope there must be the reciprocal of the slope at 3 for the function f. So that slope must be 1/5. You can draw that right there. Now, if you're like me, I like to kind of see it a little bit differently, but I drew that graph there just in case that was a little bit more helpful. Another way you can look at it is just like to make like a little chart of what we know. So on f, I have this point 3, 8, which means when we're looking at the inverse, what we really have is the point 8, 3. So if I know the slope at 3 is 5 when I'm looking at f, that means the slope at 8 must be the reciprocal of 5 here. And now we have 1/5. And we know that because by definition of the inverse, our inputs and outputs switch.